Hello, my name is Justin Self, and I want to go over problem 4-24. In this problem, they're giving us an electric field, and it looks like this. Here's the whole vector. There's an X component you can tell here, and there's also a Y component here. And it says here, produce plots like those in figure 412 that show the evolution of the electric field vector. And then they tell us some other stuff. I've also included in here figure 412. This is 412 right here. And so this is what they're asking us to produce. And so when they say produce plots, they want an X and Y axis. This one, the electric field is 0. This one, it actually has a magnitude and a direction in that way. And so on and so forth for all of these different T values, because this is a time-dependent thing. So keep that in mind as we're working through this problem. We're going to produce something like this. So I want to point something out here that the first thing they give us is at the plane Z equals 0, all right? So this is a spatial thing. They're just basically saying that the electric field is oriented in such a way that the plane Z, like none of it is in the Z direction. Cool. That's nice because I can take this term here and kill it down to 0. Nice, makes it easier for us. And let's see what else they tell us. As a function of time over one complete temporal cycle for the following cases. Okay, so this problem is actually pretty long, but I'm just going to walk through number A just a little bit for you, and then I'll show you the rest of my work and show you kind of the general format. But once you get the initial, procedure of how it works, it's pretty chill after that. I want to show you what I did. So the first case here, we're going to focus on this one here. Notice that they say EX is equal to 2EY. So what I'm going to do is I'm going to rewrite the electric field vector they give us. I'm going to use a different color so you know. And instead of writing EX, I'm going to write it the way they tell me to. They say EX is equal to 2EY. So I'm just going to rewrite it this way. 2EY times the sign of, well, the first term is gone, right? This 0 business, that's out of here. This is all we have left is negative omega t plus phi 0x. So let's write the next part, minus omega t. I can look up here. They're not messing with that at all. So cool. Let's leave it be. Negative omega t plus phi of 0x. What's that all about? Well, look right here. They give me that phi 0x is equal to phi 0y, which is equal to 0. So I can also knock that out. Those are equal to 0 for this case. Okay. Notice that for number B, C, D, and E, you're going to have different cases. Okay, all these things are changing. Okay, so just if you follow the same procedure for the other ones and just cross out what you can, that'll help. Well, I know that those are equal to 0, so boom, that's all we get. Now for the bottom, I'm not changing it at all. EY sine of looks like the same thing, negative omega t. Now, when they say one complete temporal cycle, you have to look back at this here to know what your T values are. Now, I want to point out something really, really important here. When Dr. Gillen teaches this in class, she does an example similar to this. And she does something a little bit more intuitive. Like, wouldn't you agree that this T, it means time, right? Wouldn't you agree that like pi over 4 omega time is weird? Like, who thinks in terms of like pi over 4 omega, like I'll be there, in pi over 4 omega minutes or something. So that's super weird. Here's what they're getting at. This is what Dr. Gillen does. Check this out. So she'll do like, let's just say, oops, I want to use a different pen. So let's say that T is going to be equal to big T over 8. That makes a little bit more intuitive sense. Big T is the period, right? This is a cycle. And so now we have the period. So we know that big T is equal to 2 pi over omega. And let's do that over 8. I'm going to write it as 1 over 8. And so if you think of it this way, right? Now what I can do is I can write this as pi over 4 omega, which is what they have here. And so I think it's important to think about that. Like, they didn't just pull this stuff out of thin air. These are super weird. I get that. But they're basically taking an extra step out of it for you. This to me, oops, I don't want that. I have something on my screen. You probably didn't see that. It's okay. This makes more sense, right? Like big T over 8. Like you take the whole period of the cycle, you divide it in 8 pieces. Like So let's think about it that way. So that's all they're doing. I wanted to point that out. That's all they're doing here is they're saving you the math of doing this stuff, and they're just straight giving you the pi over 4 omega. So if you're wondering where these came from, this is where it came from. But since they did it for you, let's just run with it because it's easy. So, all right, cool. Hopefully that makes sense. So what I did, you can see over here, the way I would do this is set up a table like this. For all your t values, all your x hat values, and all your y hat values. Recall that this over here is your x hat vector, and this is your y hat vector. And together they make the entire electric field vector. And so when there's a column here for the x hat, that's going to be whatever comes out of this top vector component. And then the y hat is going to be whatever comes out of the y component. That's the way I think about it. So let's go ahead and plug this in. So I'm going to say let's do the first one, for t equals 0. Okay. And what I'm doing is I'm using this blue business as like my motherboard here. Like this is the mother equation that I'm going to be using for all these different t values. I'm literally going to run through every single t value on this picture here. Recall this is the figure 412 they told you about. So you want to be using these t values from that. And so we're going to use this blue thing. We're just going to plug in all the different values of t for this whole thing. Okay, let's start with t equals 0. For t equals 0, I'm going to rewrite my 2ey times the sine of, well, negative omega times whatever t is, okay, 0. Okay, that's the top part. ey times the sine of negative omega times 0 again. And I wrote it differently, but it's the same thing. Well, I'm going to go ahead and just write it right here. I'm going to get rid of this to make some more room for us. Simplify it. So 2 times ey. Well, what's the sine of 0? Well, the way I think about that, you guys probably already know this, but the sine of 0 over here is equal to 0. See, this is all 0, sine of 0 is 0. This is the unit circle here. This is my 0. This is my pi over 2. I'm going to be doing this a lot. Okay, we draw a lot of unit circles here. Well, we have the same thing on the bottom. So you end up with something that looks like this, 0, 0. And so that's the x component, that's the y component. So up here for t is equal to 0, I'm going to write in the x component is 0 and the y component is 0. That one's pretty chill. Let's do the next one. T is equal to pi over 4 omega. So this is pi over 4 omega. Okay. I'm going to move this guy. Actually, I'm going to cut him out of here so that we can work. Okay, so let's do for t is equal to pi over 4 omega. We are using this. I'm just going to copy him and duplicate, put him here. Okay. So we get the electric field is equal to, same thing, 2 times the ey times the sine of, well, negative omega stays there. And now we're multiplying it by t, which is pi over 4 omega. Great. Now we have ey times the sine of negative omega times the same thing, pi over 4 omega. Cool. Well, the omegas cancel, of course, and all this. And so you end up with 2 times ey times the sine of negative pi over 4. And this one's just regular ey times the sine of negative pi over 4. Same thing, I do all mine. Maybe you have it memorized because you're smart, but I always draw the unit circle. So these are my little, you recall this is 0 to pi, this is pi over 2, this is pi, this is 3 pi over 2. Right here would be my positive pi over 4. So these lines are pi over 4 lines. We're talking about negative pi over 4. So from here, negative pi over 4 is right there. This is my negative pi over 4. I can see that that is in the sine direction. Sine is I think of it as the y direction. And so I know that this is a negative value. So negative pi over 4 is going to give me a negative value. Let me rewrite this really quick. I'm evaluating this part right here. So negative pi over 4 is going to be a negative value. The sine of pi over 4 is the square root of 2 over 2. And since it's a negative, I'm going to put a negative sign on it. Okay. And the exact same thing for the next one because we have the same negative pi over 4. So I'm going to do the same thing. It is equal to negative square root of 2 over 2. Now we just evaluate it. 2EY. Oops, I made a mistake. Excuse me. Did you see my mistake? I was evaluating this whole thing and I put it there. So hopefully you saw what I did. What I meant to say was that this whole expression is actually equal to negative square root of 2 over 2. That's what I was doing. Negative square root of 2 over 2. Do that. If anybody's wondering what I'm using, I'm on my iPad and I'm using Notability. I think it's the bomb. All right. So when we do this, you get the 2 here that cancel. And so you end up with, let's just redo this. That ends up with the 2's cancel. So I get a negative out in front, EY times the square root of 2 for the first one. And the second one, I get EY times the negative square root of 2 over 2, which I like to write as negative square root of 2 EY times the negative square root of 2 over 2 times EY. So that is my answer for when t is equal to pi over 4 omega. So I'm going to go ahead and put those in my table. The x component was negative square root of 2 EY, and the y component was negative square root of 2 over 2 EY. Okay, so what you're going to do is you're going to, do the same thing, follow the same procedure all the way down for all these values, right? T equals 0, t equals pi over 4 omega, t is equal to pi over 2 omega, and so on and so forth. You can do this 9 times, okay? Great, fun. Follow that same procedure. And what you'll end up with are those plots. Let me show you how to do the plots, okay? So I'm gonna go ahead and remove that, and I'll make a little plot here for you. That is my x direction, or excuse me, that's my x direction, that's my y direction. And so let's draw the first one for t equals 0. Well, over here we see t when t equals 0, x component is 0, y component is 0. So nothing's going on here. The electric field vector doesn't go anywhere. It is equal to 0. Let's do something more fun. For the second one, so I'm gonna delete my stuff there. For t is equal to pi over 4 omega, we actually have some values. I'm going to use blue to represent x, and I'll use red to represent the y component. So we see that the x component for pi over 4 omega is negative square root of 2 times ey. We don't know what ey is equal to. We don't really care because we don't know what it is for this one either. So I can still draw it as a vector. So I'll show you what I mean. Negative square root of 2 ey in the x direction. Well, I'm just going to say, okay, in the x direction, it's a negative number and it's some magnitude of square root of 2 times ey. I'm going to call it that. Great. In the y direction, I have a negative square root of 2 over 2. You notice that that's exactly half of what the x direction magnitude was, right? So I'm just going to draw it in the negative direction, and I'm going to draw it as close as I can. We'll call that maybe half, right? That's about half the magnitude of the one in the x direction. When you add these two vectors together, you get a vector like that. That is your electric field vector. Okay. So that is my little example walkthrough. I'll show you what this is going to end up looking like. So please excuse how messy it might look with all the colors, but this is my work and this is what it ended up being. You can see a lot of these little unit circles. Okay, here we go. So I ended up doing all that work, and here are my plots. Okay, so you can see we just drew that one, and you see what you see is this thing ends up getting really long here. That's because you have a -2 magnitude and then a -1 magnitude. So that's quite a bit longer than this last one. Up a little ways and back to 0. So if you can see my video, not my screen, but if you're looking at my face right now, you can see how this thing kind of goes here's the axis, it kind of goes whoop, whoop, and then it goes up in the other way, whoop, whoop, so it kind of goes like that. And so that's the idea. And so that was an example of the first one. And you're going to do the same thing for all the other letters. Just be careful when you come to these ones that look, they keep EX is equal to 2EY throughout the whole thing. But notice that phi 0x changes, right? It could be 0, 0, but also it ends up being pi over 4. Then notice that phi of y changes as well, becomes pi over 2 and negative pi over 2 and all sorts of things. So just be careful with that. That's going to make it so that you won't just zero it out like I did here, but you will end up actually putting values in for that. But it's the same exact procedure. You'll just be crunching the numbers, evaluating it, and developing a table of components, and then just drawing little plots for it. Hopefully this was helpful. Thank you for listening.